Hello and welcome to Godot Aerodynamic Physics version 0.8. This version brings many new fantastic features. Let's jump right into it. The demo has been significantly expanded, now featuring 11 unique aircraft. The old demo plane is still present and hasn't had any significant changes. The first of the new demo aircraft is the Cessna 172 Skyhawk, a common civilian airplane. The Skyhawk is the most produced plane in the world, with more than 44,000 having been made. It's light and fairly agile, but ultimately it's limited by its engine and propeller. Our next aircraft, the Grumman F-14 Tomcat, was first deployed by the US Navy in 1974. It's notable for its variable sweep wings, split throttles, and air brakes. Although capable of a ludicrous top speed of Mach 2.3, the size and weight of the Tomcat limits agility greatly. Despite what the movies have led you to believe, the split throttles aren't nearly as useful as they may seem. There's also another variant configured to have mouse controls similar to War Thunder. This control scheme utilizes the direction target feature of the flight assist to produce natural control inputs. The natural control inputs make for a much more casual flying experience that I could even call relaxing. Following the Tomcat is the AIM-9 Sidewinder missile. First entering service in 1954 with the US Navy, the Sidewinder is still in current use by the US military. It utilizes the same mouse controls as the mouse-controlled Tomcat variant. This would be a great starting point for implementing missile guidance algorithms. Now, to change the pace a little, we have a few aircraft from the world's newest former superpower. First comes the Sukhoi Su-57 Felon, entering in at a slim 65,000 pounds. The Felon features thrust vectoring engines capable of 3 axes of control, which allows for extreme maneuverability in the post-stall region. Although the practical advantage of thrust vectoring in this manner is non-existent, it makes for an enjoyable flight experience. The Felon is accompanied by the Sukhoi Su-47 Berkut. While the Berkut is known primarily for its reverse-swept wings, it also features forward canards as a primary control surface. The canards are also a key element as they bring the center of lift forwards, which is necessary to compensate for the reverse-swept wings. Back on the American front comes the Northrop B-2 Spirit bomber with its unconventional flying wing layout. First introduced in 1997, it is the most expensive airplane to exist, requiring air-conditioned hangars to prevent the radar-absorbing skin from degrading. The Spirit is not capable of supersonic flight and is only able to control yaw using wingtip air brakes as well as differential thrust. This airplane is truly a torture test for the quality of the simulation and the effectiveness of the flight assist. I feel that it's poetic to complement the B-2's massive size with one of the smallest aircraft available, like a consumer quadcopter. Control is achieved realistically by varying the speed of each propeller individually. This highlights the improvements made to the propellers and the control system quite well. The quadcopter only has angular control mode, missing the ubiquitous horizon mode, which limits ease of flight greatly. This is one area of the plugin that still needs improvement. To contrast the relative simplicity of the quadcopter, the next aircraft is the Bell Boeing V-22 Osprey. The Osprey is a tilt-rotor aircraft which has a rather complex control scheme due to the tilting and counter-rotating engines. The Osprey was first flown in 1989 but wasn't fielded until 2007. This was due to cost overruns as well as continually changing project requirements that left the Osprey in limbo. The Osprey greatly utilizes the updated control system, but we'll have to get into that later. And finally, I would like to present the Sikorsky UH-60 Blackhawk helicopter, a notable inclusion due to my past difficulties with creating an accurate helicopter rotor simulation. The Blackhawk is the replacement for the timeless UH-1 Iroquois Huey. Entering service in 1979, the Blackhawk is the most used helicopter for the US military. This addition is only possible due to the new Disable Lift Dissymmetry option on the Aero Propeller class. Although it degrades realism slightly, this workaround is very important for any use of helicopters to avoid difficult and often performance-intensive rotor simulations. On the trend of rotors and propeller improvements, propellers also have a very welcome quality of life change. They now update in the editor, showing the blades that will be present in the running project. Besides being a helpful visual aid, this change also improves the accuracy of the debug vectors in the editor for aircraft that utilize propellers. And to follow, there has been further improvement to the debug vectors. They should be more accurate to the real simulation result and give a clear indication of where forces are balanced. Part of this improvement is the addition of thrust vectors. Thrust displays as a magenta color and is calculated as the component of a node's force which points in the same direction as linear velocity. Due to how it's calculated, this makes the thrust vector only really useful for airplanes. Editing aero surfaces has been reworked slightly so that you can directly adjust the area and aspect ratio. I have found this change particularly useful when creating and tuning propeller blades. If you find some of these changes confusing or difficult, or you just can't figure out what a feature does, fret not. With the Godot 4.5 update, the in-editor documentation has been fixed and is now accessible. Press F1, enter the class name, and open the documentation for any class. Importantly, this documentation gives examples on how to properly extend these nodes with scripts without losing functionality. To mirror this, there are also more wiki-style docs on the GitHub page, which will provide some text-based tutorials as well as extended class reference. Currently, it's a mirror of the in-editor documentation with a few extra pages for installation and development info. It's a little bit rough and doesn't have very many pages, however, it is being continually improved. Not least, and most certainly not last, I would like to introduce the update for the control system. The main improvement in this version is that control axes can be added and removed to fit the need of an aircraft. For example, the Osprey utilizes a unique control axis for the rotor tilt. These control axes are identified by the axis name, and there's no limit to how many or how few axes can be used. Control axes are identified by the axis name, and there's no limit to how many or how few axes can be used. Otherwise, the configuration inside each control axis should be familiar, as it has remained the same from previous versions. Similarly, the configuration of controls on aero influencers should be very familiar from the previous version, though the axis name must be specified. Now, for the groundbreaking features of the control system. First, there is an axis flip setting, which allows for easier configuration of oppositional controls such as roll. To complement this feature, automatic mirroring of aero influencers has been added. Mirroring is simple to configure, only requiring the mirror axis to be set. Hopefully, these two features should provide a massive improvement to the workflow of creating and modifying aircraft. A more niche feature which has been added is scriptable expressions for control contribution. Scriptable expressions allow for dynamic contribution values. These expressions use GDScript and can use functions and variables from nodes. The result from these expressions will overwrite the contribution value on that axis. Expressions are used on the V-22 Osprey to limit when certain control actuations are used, which is necessary to handle control differences between vertical and horizontal flight. When installing from the Godot asset library, the install path no longer needs to be manually changed for proper install. This is in contrast to previous versions where the path had to be manually set, which was prone to error. With some configuration in the asset library, and aided by release automation, the file structure of the releases now works out of the box. The final edition isn't flashy, but I've created automation for releases. This will allow for more frequent updates, bug fixes, and overall a lot of time saved. Because of this, you can expect more frequent patches, bug fixes, and content updates. Hopefully, with the fixes for the documentation, a video won't be needed for every version that is released. Though new features and updates will still be included alongside future videos. If you've made it this far into the video, and I really mean it, thank you. I have to apologize for how long it's taken to release this update and this video. Originally, this video was going to cover a much larger set of topics, but it ended up being too long to manage and efficiently produce. Because of this, I decided to split the topics from that video into a few smaller videos that should be more manageable to create, so keep an eye out for those videos in the near future. As a reward for staying all the way until the end, enjoy this sneak peek at a few of the upcoming projects.